Hi guys, this is Carla. I'm going to explain you the integral of the exponential function and we are going to solve some exercises. So first thing you have to know are two formulas that are very important. So the first formula is the integral of a to the u times the u equals a to the u over natural logarithm of a plus c. And the second formula is the integral of e to the u times the u equals to e to the u plus c. These two formulas, you have to learn them by heart, and once you have learned them, please write them on your index card. The difference between one and the other is basically that the first formula, we're going to use the first formula when we have to integrate a constant. And the second, we're going to use the second formula when you have to integrate e to the u. So let's say, for example, that we have our first integral, which is the dx over e to the x. First thing you have to rewrite is the e to the x on the denominator, because it is impossible for us to integrate an expression on the denominator. So we will change it to the numerator, changing the sign of the exponent, and that will be the integral of e to the negative x times dx. So in this case, as the exponent is something different from x, we're going to do that u. So u is going to be equals to negative x, and the differential of u, it is going to be minus dx. As we don't have minus dx, but we have dx, we have to multiply du times negative 1, so we have our exact other factor. And this, changing the variable of integration, this will be the integral of e to the u times negative du. So write the constant out of the integral sign, negative integral of e to the u times du, and using the second formula, the integral of e to the u, it's e to the u plus c. So my function will be actually negative e to the u, which is negative x, plus a constant. That is my integral, my indefinite integral, or my original function. Let's do the verifying. If the function is negative e to the negative x, the derivative of the function will be the constant, which is negative 1, times the derivative of e to the negative x, which is e to the negative x, times negative 1, which is the derivative of the exponent, plus the derivative of a constant, which is 0. So multiplying, negative times negative is positive, so this will be e to the negative x times dx, which is the first integrand that we have at the beginning of the exercise. Let's move on to our second example. We have the integral of e to the x over 1 plus 5 e to the x times dx. So as we don't have, again, a rule to integrate a quotient, we must use substitution rule. The important thing is knowing what is going to be my u. So in this case, I'm going to choose u as the expression on the denominator. U is going to be 1 plus 5 e to the x. So the differential of that will be 5 e to the x times dx. Is that the other part of the integral that we have? It's similar, but it's not exactly. What is missing is dividing du over 5, or both sides over 5. So I have as a factor e to the x times dx. So let's substitute or change the variable of integration. That will be 1 over u times du over 5. Writing the constant out of the integral sign, we will have 1/5 of the integral of 1 over u. And using the basic rules, we know that the integral of 1 over u is natural logarithm of u plus c. So let's substitute back our variable of integration, and that will be 1/5 of natural logarithm of u, which is 1 plus 5 e to the x plus c. That is my indefinite integral, or my antiderivative. Let's use differentiation in order to check our results. If the function is 1/5 of natural logarithm of 1 plus 5e to the x, the derivative of that will be the constant times the derivative of the function. And as you can remember, the derivative of natural logarithm of u is 1 over u times the derivative of u. So the derivative of 5e to the x is 5e to the x. And the derivative of a constant, which is 0. By simplifying this expression, we will have that dy equals to e to the x over 1 plus 5e to the x times dx. And that is exactly the same expression that we have at the original integrand. A third example will be this, the integral of 4e to the natural logarithm of x over x. So what is going to be my u? Again, we don't have a rule to integrate a quotient, so we must use substitution rule. In this case, we are going to use u as the exponent of e, which is natural logarithm of x. And we know that because if you know the differentiation rules, the derivative of natural logarithm of x is 1 over x times dx. And this is very similar to what we have here in the original integrand. The only thing that is missing is that we have to multiply both sides times 4. So we have 4 over x times dx. Okay? Changing the variable of integration, that will be e to the u times 4 times the u. Constant out of the integral sign, e to the u times the u is the second formula that we have learned today, and the integral of is e to the u plus c. So substituting back, it will be e to the natural logarithm of x plus c. That's my definite integral. Let's do the verifying. Verifying will be the derivative of y with respect of x is 4 e to the natural logarithm of x times the derivative of natural logarithm of x plus the derivative of a constant, which is 0. And so the y will be equals to 4 e to the natural logarithm of x over x times dx. This is dy. And finally, one last exercise, the integral of 14x e to the x squared. It will be not so difficult to find out that the u value is the exponent of the exponential function, which is x squared, because the u will be 2x times dx, and it's similar to what we have 14x times dx. We just have to multiply the u times 7, so we will have 14x times dx. And changing the variable of integration, this will be e to the u times 7 du, constant out of the integral sign, and that will be 7 times e to the u times du. And by using the formula, you know that the integral of e to the u is e to the u plus c. So let's go back to our original variable of integration, which was this. So we have our antiderivative or indefinite integral 7 e to the x squared plus c. And let's do the verifying. So we have everything verified. The derivative of a constant times a function will be the constant times the derivative of the function, which is e to the u times the derivative of u, that in this case is 2x plus 0. We are using the chain rule, as you can see, and that will be 14x e to the x squared times dx, which is the original integrand. Hope this video was useful. Those exercises, as you know, are on your notes. So I will ask you to write all the exercises on your notes and continue with set number 9, which is going to be a set of integral of exponential functions. Remember that if you have problems or doubt, just raise your hand and I will go to your place. See you later.